But now, as this mysterious object known as Oumuamua barreled through our cosmic backyard in 2017, telescopes like those at Pan-STARRS turned their gaze upon it. And what they started to reveal is something we may not be ready for. Because some like Harvard astrophysicist Avi Loeb are now asking, what if this isn't just a visitor? What if it's something more? This question, though speculative, has sparked a global conversation about the nature of interstellar objects and our ability to understand them. The discovery of Oumuamua marked a turning point in astronomy, forcing scientists to reconsider what might be traversing the vast distances between stars and what those objects might mean for our understanding of the universe. The detection of Oumuamua was a monumental event, not just for its scientific implications, but for the way it challenged our assumptions about the cosmos. Astronomers had long theorized that interstellar objects, debris from other star systems, could occasionally pass through our solar system, but none had ever been observed until 2017. The object's discovery was a testament to the advancements in telescope technology and sky survey systems, which have become increasingly adept at spotting faint, fast-moving objects. The Pan-STARRS-1 telescope located on Haleakala in Hawaii was designed to scan the sky for near-Earth objects that could pose a threat to our planet. Its wide-field imaging and high sensitivity allowed it to detect Oumuamua, a faint object moving at an extraordinary speed. This wasn't a typical asteroid or comet orbiting the Sun. It was something entirely new. A visitor from beyond our solar system, carrying with it clues about the environments of distant stars. First detected on October 19, 2017, the object now officially named 1IM Oumuamua appeared on the radar of Pan-STARRS, a high-speed sky-scanning system designed to catch potentially hazardous objects before they surprise us. But this time, Pan-STARRS didn't find just another asteroid. What it caught was different. Its speed exceeded 196,000 mph relative to the Sun, far faster than any known solar system object. Its orbit didn't follow any of the known gravitational loops of comets or inner solar system wanderers. Instead, tracing a hyperbolic path that confirmed its interstellar origin. And when astronomers reversed its trajectory through simulation, its origin pointed not to the Oort cloud, not to Neptune, but to interstellar space, possibly from the direction of the LRA constellation near the star Vega. Though its exact origin remains unknown, this wasn't a leftover rock from the formation of the solar system. This was something that had been traveling through the dark for potentially millions of years. Unseen, a relic from another star system that had wandered into our solar domain. And now it had crossed the threshold into our solar domain. But the deeper mystery wasn't just where it came from. It was why now. Because before 2017, we had never seen a single interstellar object. Now we've seen two with 2I Boris detected in 2019. And each one has been stranger than the last, raising questions about how common such objects might be and whether our detection capabilities have only recently reached the point of noticing them. The discovery of Oumuamua was a wake-up call for astronomers, highlighting the limitations of our previous observations and the potential abundance of interstellar objects passing through our solar system unnoticed. The Oort cloud, a hypothetical shell of icy bodies surrounding our solar system, had long been thought to be the source of long-period comets. But Oumuamua's trajectory ruled out an origin within our system. Its hyperbolic orbit indicated it was not bound to the Sun's gravity, meaning it would pass through and exit our solar system, never to return. This was a profound realization. Our solar system is not an isolated bubble, but part of a larger galactic ecosystem where objects from other stars can visit. The question of why now is less about cosmic timing and more about technological readiness. Before the advent of advanced sky surveys like Pan-STARRS, such objects might have passed undetected. The second interstellar object, 2I Boros, discovered by amateur astronomer James Boros in 2019, further confirmed that interstellar visitors might be more common than previously thought, with estimates suggesting several could pass through our solar system each year. After the initial confirmation, scientists around the world scrambled to get time on powerful observatories like the Hubble Space Telescope and ground-based telescopes designed to peer deeper into time and space than anything before them. These were now focused on something much closer and potentially much more unsettling. Oumuamua's brightness didn't match its apparent size. Based on the intensity of the light it reflected, it should have been massive, perhaps kilometers in diameter. But measurements suggested something smaller, perhaps 100 to 400 m long, which means the surface isn't behaving like typical rock or ice. It was highly reflective, possibly like a dust-free surface or a reddish organic-rich coating, though not necessarily hollow as some early speculation suggested. Harvard astrophysicist A.I. Loeb, who previously suggested that the 2017 object Oumuamua might have been artificial, once again stepped forward. He urged scientists to look for non-gravitational acceleration, small deviations in motion that can't be explained by the sun's gravity alone. Such deviations were observed in Oumuamua, suggesting possible outgassing of unseen volatiles like hydrogen or carbon monoxide, though no comet-like tail was detected. If such deviations indicate more than natural processes, they might suggest the object isn't drifting but navigating. A hypothesis Loeb explored in his book Extraterrestrial. And if it's navigating, then we're not watching a rock. We're watching a decision. Though this remains a highly speculative hypothesis with no supporting evidence beyond the observed anomalies, the non-gravitational acceleration of Oumuamua detected through precise tracking of its trajectory was a significant puzzle. Most astronomers attribute it to outgassing where solar heating causes volatile materials to vaporize, providing a small thrust. However, the absence of a visible coma or tail, typical of comets, made this explanation contentious. Lowe's hypothesis that the object could be a solar sail or probe from an extraterrestrial civilization gained attention, but was met with skepticism as it relies on extraordinary claims without direct evidence. The mainstream scientific community leans toward natural explanations such as a nitrogen ice composition or a fractured surface releasing gas unevenly. The debate over Oumuamua's nature has fueled discussions about how we interpret unusual celestial objects and the thresholds for considering artificial origins. To understand how significant this discovery is, we have to look at the two interstellar objects that have been confirmed. In 2017, Oumuamua burst into the scientific world with its strange elongated shape. Estimated to be 10 times longer than wide. Lack of comet tail and mysterious acceleration after passing the Sun despite showing no clear signs of gas or propulsion. Its reddish hue detected through spectroscopy suggested exposure to cosmic rays over millions of years, similar to some outer solar system objects. Then in 2022 Boris entered the picture clearly. A comet, yes, but faster and more volatile than most solar system comets. With a clear comet tail confirming its icy composition, rich in carbon monoxide. With each of these objects, we were left with more questions than answers. But Oumuamua is different. It combines an inexplicable brightness with a trajectory unlike any solar system object. It doesn't behave like a typical rock. But it also doesn't fit neatly into the category of a comet. And now astronomers